So now we're going to put together all of our integer rules, operations, things like that, and apply this to graphing. But ironically, you already know how to do this. So we've taken all the new rules to show you how to do something that you've already known how to do. But we are going to extend it today. The first objective in here in Chapter 2, Section 6 is entirely a review for you. You all know how to do this, but I'm going to review it with you, and we'll go through it quickly. Coordinate plane consists of 4 quadrants, we call them. The quadrants are numbered 1 through 4, starting in the top right, and then they work counterclockwise all the way around. The quadrants are created by 2 intersecting lines, and those 2 lines are called your axes. You have your x-axis, which is your horizontal axis. You have your y-axis, which runs vertically. Those 2 meet and create a right angle, perpendicular you could call them. And where they intersect, that location is called the origin. So the x-axis, just think of it like this, a horizontal number line. A y-axis is a vertical number line. And where the x and y meet, that's the 0 point on both number lines. So that's the physical description of the graph. When you graph points on the coordinate plane, we're graphing what we call ordered pair, or sometimes they call them coordinates. So if you look at the example here, for number 1, letter A, point A has the coordinates of -4, 3. Now, since you guys already know how to graph these points, can you tell me about what this means? This -4, 3. If you want to tell me how to graph it, how to plot it, that's fine. Olivia? Exactly. The -4 is on the x-axis. We call that your x-coordinate. The 3 is the y-coordinate. Just think, like an alphabet. X comes before y. In an ordered pair like this, x always comes before y. It has to. It's not like it changes. It has to. So then how would I locate this point on my graph up here? She gave us the coordinates, but how would I actually do that? Victoria? So right here. Go up to +3. So like here, but I would go straight up from -4. Okay? So I would go up 3 from there. If I put a point, I would label that point A. I agree. Every time you graph, you begin at the origin. That's what the word means, right? Origin, the beginning. That's where you start. So if it's -4, 3, I start here. I go -4, because we know that's the x-coordinate, and then I go up 3. All right, tell us how to get to letter B. That was your one review. Now you guys this should have triggered some memories, I would assume. Matt? Okay. 3, and then up 7. There's your point B. All right, somebody take us to C. Go ahead, Justin. There you go. And then let's close it out with D. Amelie? Go to the right, 6, down 3. I agree. That puts point D somewhere right there. All right. Now here's the thing. In order for us to land in these different quadrants, give it time to think, there are some rules that you could follow. You could identify. If I look at an ordered pair, I can tell you immediately which quadrant it's located in based on the signs of the coordinates themselves. So if I wanted to land in quadrant number 1, what can you tell me about the two coordinates, or what must be true about the two coordinates for that point to be located in quadrant number 1, which again is up here in the right? Ashley, they would have to both be positive, right? Move to the right and move up. So my two coordinates are positive, positive. How about quadrant 2? What would put me in that range or in that region? Dominic? A negative x value followed by a positive y value. Good. Number 3, or quadrant 3, should say. Misty? Both negative. Negative x, negative y. What about quadrant 4? Victor? Positive followed by a negative. All right? Well, let me extend that. What if I have a point that's on the x-axis? What can you tell me about those two coordinates, sign-wise? Or not, maybe not even sign-wise. What can you tell me about the coordinates that would land on the x-axis? Any point. Andrew? One of them would have to be 0, you said? I agree. Which one? The y-coordinate, exactly. So this second value has to be 0. What about the first value? Does it have to be negative? You guys are saying no. Does it have to be positive? Could it be either? So the first x value could be either positive or negative. You just know that that second term, or the second coordinate, which is the y, has to be 0. All right, so then what if I wanted to land on the y-axis? Vertically. What's going to get us there, Matt? Second one would, and then the second one would be, yeah, same thing. Could be either positive or negative. What are the coordinates of the origin? I don't think we talked about this yet. Amelie? 0, 0, yep. Beginning. It's the beginning for both of them, so 0, 0. All right, so that's the basics. Everything, I doubt there's anything that I even said in there that you didn't know already. So we're going to apply it now. So let's look at an example here. Example 2 says this class is playing a quiz game. 2 kids, Marlene, Samantha, score is 3 points. The difference, I'm sorry, between them is 3 points. X represents Marlene's score, Y represents Samantha's score. Make a table of possible values for X and Y, and graph. This is a lot of what you'll be doing here in the next couple of days. Not just plot the point, -2, 5. You know how to do that. This is just an extension of that. They're talking about a quiz game where one person's score is represented by X and the other person's score is represented by Y. It tells you that one person has 3 more points than the other, but it fails to say which one has more. We want to clarify that, okay? So let's assume that she has more. Marlene, the X value has more than the Y value. Well, tonight on your homework, when it asks you to create a table of values, this is what you're going to make. But you get to pick the X values. These are your choice. You can pick anything you want. But I will caution you, look at the graph that I have here. Because ultimately you're going to have to graph these points, and look at where my X coordinates range from. I don't want to pick an X value that's 20, because either I'm going to have to adjust my scale, or I'm going to have to create a bigger graph. and I don't want to do either. So I'm going to keep my points so that they fit on the grid, and now I like to keep them close to the origin. It just makes everything a little easier. Numbers are smaller, easier to work with, things like that. So why don't we start with 0? It says X is Marlene's score, so that means that if she has 0 and she's winning the game, or she's at least beating the other player, what would the Y score have to be if X is 0 based on that description? What would the Y have to be? David? Not 3. There was a key ingredient you maybe missed. Sophie? -3, because the X person is winning. So that means the Y value is 3 less than that. So our coordinates are 0, -3. So if we plot that, 0, -3, that point goes right there. All right, so I'll pick another one. What if X is 2? What would Y have to be? Victoria? -1. So go ahead and plot the point 2, -1. 4. Ella? 1. And just for good measure, let me put a negative number in there. What if I went -2? -2. Justin? -5. So if you look at these points, first of all, it looks like you could connect them with a straight line, which means they are linear, and that's important. And that's true because you're maintaining the same rule throughout these set of points. So the rule would be X minus 3 could give you your Y value, right? Whatever I said for X, a lot of you just subtracted 3 from it. You could have also said if this would work. Is that a consistent? If you can't get something consistent out of your rule, then that's not the rule you want. All right? What if I did this? Yes. It does equal the same thing every time. Think about it. If I took this column and subtracted this, what do I get every single time? 3. There's your rules for subtraction, right? 0 minus a -3 is like saying 0 plus 3. 2 minus a -1 is 2 plus 1. And it says before the difference between their scores is 3. So that means when I subtract, I get 3. So either one of these two rules would work in describing this situation, this scenario. All right, let's look at one more. Let's see if we can get another one here to get us started. Similar type problem, except this is 2 golf scores have a sum of 2. Remember, you picked the X values. So same type of graph. So let's say X maybe is 3, 2, 0, -1. I don't know, just picking some of those. Now we know that X plus Y has to equal 2. The sum of these two scores is 2. So if X is 3, what would I have to add to 3 to get me 2? Down? -1, yes. So 3, -1 is one of the coordinates. What would 2, or what would the y be if x is 2? Olivia? 0. Zero x. Victor? 2y. And x is -1. Y would have to be what? Ella? 3. Now, if you describe what you see here, there are a couple of key words. Well, one major keyword, and that word is linear. When we say that points are linear, that means that they can be connected with a line. And this equation that we wrote confirms that these would, in fact, be linear points, create a linear equation. Yeah, Sophie. And it's what? What's flipped around? Oh, I see, the coordinates. Okay, I was looking at like the points. I'm like, wait, yeah, she's exactly right. You can see that the other side is just in the reverse order, but yeah. All right, hold on. Tonight, your homework